Hi guys, today we're looking at isotopes. So, what is an isotope? Well, basically, an isotope of an element or a certain kind of element within the periodic table has a different number of neutrons um, compared to like others or the average version. So, for example, if we take carbon, so I'll put a circle around it. So as you can see, um, it says the proton number is 6. So it has 6 protons. That doesn't change at all. Otherwise, if it did, then we'd be moving on to other elements. Um, but what does change is the mass of the element. Now, usually a proton and neutron is has a mass of 1 atomic mass. So if we write this out, if I write this out, so if we put masses, so a proton equals 1 atomic mass, neutron equals 1 atomic mass, and an electron, it's not 0, but it's so like small in terms of its mass. We just call it 0, just for simplicity. So yeah, this is important because we need to know why is the bottom number here different? Why has it got like a decimal, right? If you look at some others, like say for example, potassium here, that has a proton number 19, whole number, that makes sense. But then a atomic mass of 39.1. So are we saying that you can get 0.1 amount of a neutron? No. How it works is usually when scientists measure the proportions of a the different elements of different isotopes. So if we have a look at carbon 12, it means that the mass of the carbon atom is 12. So therefore it has 6 protons and 6 neutrons. And we know that the majority of carbon atoms are carbon 12. So yeah, but we know it goes up because we know there are other isotopes, there are other versions of this carbon atom. So yeah, the proton number stays the same, but the and the electrons too, but the number of neutrons changes. So usually, in terms of carbon, there's 3 common ones. There's carbon 12, carbon 13, and carbon 14. So, as you can guess from that, carbon 12 has a mass of 12. Carbon 13 has a mass of 13, and carbon 14 has a mass of 14. So, where does this additional 1 come from? Well, if we take carbon 12, in fact, if I just type that out again, so if we have carbon 12, right, the proton number never changes, otherwise it would change into a different element. Like for example, if you changed if you took away a proton, it would become boron. It wouldn't be carbon, because carbon's unique to its proton number. So, therefore, the only number that I can change is the neutron number. So 6. So we know 6 as is the number of protons. It don't matter about the electrons. We know there'll be about 6 electrons, but electrons don't really have any mass. So therefore, if we do 12 minus 6, we find out the number of neutrons, which is 6. So as you can see there are 6 neutrons. Oh, if I span that out. So let's apply the same reasoning to carbon 13. So carbon 13. So 13, the total mass. We know that the number of protons can't change. Remember that. So it's minus 6. Therefore, 7 neutrons. Sorry. So we'll do the same for carbon 14. So it has an atomic mass of 14. Proton number cannot change, so it's 6 minus 6. That equals 8 neutrons. So there we go. So we can determine that an isotope of an element is basically dependent on how many neutrons that particular atom has. And also don't forget that because you might see like a decimal as the atomic mass in the periodic table, it's not talking about the actual atom will be 12.01. It means taken as an average of all the atoms. So because it's like really close to 12, we know that pretty much most of all carbon-12 atoms that are in existence have 6 neutrons. We know a very small fraction will be carbon-13, so have 7 neutrons, and a very small fraction will have 8 neutrons. And that's how isotopes work, and how we work them out. And you can get isotopes of all sorts of different all different elements, you know, particularly the further you go down, like uranium, and yeah, generally that as you go further down, generally the atoms have a greater variation of the neutrons. Like for example, if you look at mercury here, 80 proton number, but like 200.59 atomic mass. If you remember, if we do a quick calculation, so if it's 200 and we minus the proton number, so that's 80. Remember, we can't change the proton number, so it's there. That is 120 neutrons. That is 40 more than the number of protons, which is 80. So obviously there'll be a lot more isotopes of mercury than the ones as you go further up, because generally it's more unstable the more neutrons an atom has in comparison to its proton number. So yeah, that's isotopes. Hopefully that was helpful, and hopefully I can make another video so we can learn more about atoms. And see you then. Take care.